Welcome to our new video, Architecting Heavily Dynamic Visualizations using React, Redux, RxJS, and D3.js. I have organized this presentation into three. First, I will show the data that I used for the analysis. Second, I will explain the purpose of this visualization, and then we will go over the interface. Third, I will discuss my thought process for coming up with this visualization, and I will show my code, and then I will discuss how I integrated the four technologies that I have talked about, that is React, Redux, RxJS, and D3.js, to come up with this visualization. So I will begin by showing the data. Let me pause and go to my folder here. So the data is under the public folder. Under the public folder, we have the data folder. The data folder contains two folders, area data chunks and population data chunks, and three files. So I will begin with the population pyramid data. This is the full data set that I used for this visualization. So the columns are region, year, age, male share. So the columns are region, year, age. This is the age group here, and the median age group, the median age, and the median age group. So we have the shares of every gender to the total population for every year. So these ones here, they are long formatted, but I'm taking care of these two. They are longly formatted by Excel, but I'm taking care of them when drawing. That is 05 September and October 2014. So the data contains over 700,000 laws, and it spans 1950 to 2100, and we have 219 countries. So this is a sample of the data of the above data, which I used for developing the application, since it is better to develop an application with a subset of the data rather than using the full data set. Then we have the area chart data. Here it is. We have region, we have year, and then we have the shares of labor force, old and young, the total population for every country in every year. So this data here has about 33,000 laws. So that is it about this data. But before I go to the project, you will notice that because these two data are bulky, these two here, they are about 60 MBs, I decided to chunk this data into 10 groups each. For example, here we have area group 1. This contains the first chunk of 20 countries. So the same for the population data chunks. It contains 10 chunks, and each chunk contains about 20 countries, so that in total of them we have 219 countries. So loading data in chunks is better for memory management. So that's the reason why I decided to chunk this population data and the area chart data into chunks, as you can see in the application. So that said, let's go back to the project. So if I click here start, you'll notice that because we had already gotten to the year 2100, now if we click resume, we are counting backward. The interval is 1 year, and the speed is 100 milliseconds. We are counting backward. So if we clear the inputs and restart, then we are starting from 1950 onwards. So the purpose of this visualization is to, okay, let me click here reset, is to help the user compare the population pyramid or the age structure of a country in a given year relative to 1950 or compared with 1950. For example, this is the projected population for Albania in 2100. the median age will be 63.31 years, and it will have risen from 19.65 years in 1950. If we select another year here, you will notice that if I type an year that is less than 1950, I'm rendering the population for 1950 by default. If I type for an year that is greater than 2100, I'm rendering the population pyramid for 2100. So I'm taking care of these edge cases. But now I wanted to illustrate that if I type an year here, for example 2020, then I'm showing the population pyramid for 2020. So this is now the population pyramid for Albania in 2020, or still I can type 2024 compared with 1950. In 2024, its median age is 38.17, but it was 19.65 in 1950. So I can select any other year here. For example, I can type or select 1990. I can type 2070. And also, if we click here resume, we can also select an year when the visualization is playing. For example, I can select the year 2000. I can also select an year like 2030, and then when the animation is playing. Then we have the interval input. The interval input is the increment amount. So if I type here, for example, okay, because you are almost in 2100, I can click here, clear input and restart. If I type like 2, then the increment or the year increment interval will be 2. If I delete that and type 5, then the increment will be 5 years. So this one I set it to lie between 1 and 10. So I can select any increment between 1 and 10 years. And when we get to 2100, notice that we are changing the sign of this interval input here, because we cannot count going forward again, because we are already in 2100, but we can count backwards. So if I click here, then I'm counting going backwards. So let me click here, clear inputs and restart. If I click okay, so I have explained about the year input, the interval input. Let me now explain about the speed input. So I can change the speed, for example, to 300 milliseconds. I can change it to 500 milliseconds. So so the speed lies between 100 and 1000 milliseconds. So that's why if I put 1000 here, then we are showing the visualization for a country, for a country in a given year in every second. In every second, we are rendering the visualization. But if I delete 10 there, then in every 100 milliseconds, we are rendering the visualization. Then there is the year input. The year input helps us to navigate between the different years. And we can also navigate between the different years when the visualization is still playing. We can navigate to different years when the visualization is still playing. The same for interval. So if we click resume, yeah, now we are in 2100. If we click clear inputs and restart, so if we can select the highest interval slider of 10, and you will note that when we are selecting the different values for the interval slider here, then that value is being displayed here inside the input. The same for the year slider. If we slide to a different year, then we can see the value here. we can see the current value of the slider in that input. Now I have explained about the year input, the interval, the speed, the year slider, the interval slider. Then we can go to the area chart. So when the visualization is playing, for example, and we click here, area chart, then we can see the area chart for that country between 1950 and that year. Okay, if I may now click here, if I may now clear inputs and restart and select area chart, notice that we are keeping track of the year using the state. We are using the state to track the current year. I will explain about the state management towards the end of the video, where we will have a look at the code. So I'm using Redux to keep track of the current year. So I can resume, and the visualization will keep playing. So if we go to the area chart, the same controls will work like in the population pyramid. We can select a random year, we can resume, we can pause, we can resume, we can reverse, we can clear inputs and restart, we can select a random year, and if we get to 2100 and click start, then we are counting going backwards, because already we were at 2100, and 2100 is the last year. So we can also pause the animation going backwards, and we can resume. So that is basically about these controls here. We have the year input, interval, speed, year, these two sliders. We can change the visualization, we can resume, we can pause, we can start, we can reset, and we can start, we can select a random year, and we can toggle between the two visualizations like this. So that is it about these inputs. Now I go to the sidebar here. So when I hover over a sidebar, I'm drawing the population pyramid for that country in 1950. So for example, if I hover over Italy, this is the population pyramid for Italy in 1950, and I can compare it with its projected population in 2100. Its median age will be 54.19. And here, these labels are showing the share of every age group relative to the total population. For example, the share of males in 2100 in Italy will be 1.8, but for females it will be 1.7. It will be 1.7. So the blue color indicates that the shares of the total population in that age group is greater than the share of the other gender in the same age group. So for example, the share of males aged between 5 and 9 in Italy will be 1.9, the projected will be 1.9, and the females will be 1.8. However, this one here, ages 85 to 89, there will be more. Starting from age group 75 to 79, there will be more females. Females are expected to live longer in many countries compared to males. So that's why the shares of females in this age group is higher or larger compared to the females. So we can hover over any country, and we will render its population pyramid for the default year, that is 1950. Then we can clear and restart. I have talked about these buttons, and the controls will work for any country that is selected. The controls will work for the selected country, and we can toggle between the population pyramid and the area chart. Next, let me show you that this data here is the countries are sorted by median age in descending order by default, but we have the button here for sorting sorting the data in every chunk. For example, Albania is the oldest in chunk 1, but if we click here sorted descending, then the Bosnia and Herzegovina is the youngest but now it is the youngest in chunk 1 of 10 because we have 10 chunks. We can load the different chunk here, and because we are loading the data from the folder, that's why you are seeing these loading indicators here. So if we go to the head of the list, now we have loaded the data in chunk 10 of 10. We see that Niger will be the youngest. If we go back to population, if we toggle to the population pyramid, we can see that in 1950 the median age in Niger was 14, but it is expected to be 30 in 2100. So Niger, Chad, Benin, Cote d'Ivoire, Democratic Republic of Congo, Somalia, these African countries, Senegal, Mozambique, Solomon Island is not in Africa, but the rest of these African countries will be very young. So that is it about the interface. I will now explain about the code. So let's go now to the code. However, before we do that, I would like to share my thought process before coming up with this visualization. So the first step was to come up with some sketch using this draw.io tool. So here I decided that I would have the sidebar. This will be the sidebar component. Then down here, I decided that I would include the controls component. And under the controls component, inside the controls component, we will have a section where we will be toggling between the two visualizations, the population pyramid and the area chart. When we toggle each of these, then the figure was to appear here. So I needed to have this picture very clear in my mind, and so that I don't get confused along the way, as it has always been when I'm making these visualizations. Then, when I toggled to area chart, this is the area chart here. This was the visualization that I expected to see here, and the sidebar and the controls and these components here were expected to remain the same, but the only thing that was expected to change is the visualization when we toggle between the population pyramid and the area chart. Otherwise, all the other components remained the same. So having had a clear picture of what I wanted to make, I decided to build a React counter to mimic what would be happening in the main visualization. So this counter, I can move to a specific number. I can also pause, I can resume, and you can see it is counting up here. I can also change the milliseconds probably to 200 to 1 second, so that a number here is being rendered every second. If I delete 10 there, a number is being rendered every 100 milliseconds. I can randomize move to number, and you can see that the sliders down there are changing and this number is changing. Then I can clear all inputs and restart. The default here was 0 and 1000. So basically this counter was to count a number between 0 and 1000. So that was I included the capability for resetting, for pausing, for resuming, you can see the counter is counting here. When we pause, then the counter pauses. When we resume, then the counting continues, and yeah, that is it. So the moment I had a clear picture of how this visualization would work, you can see the sliders are also working perfectly well down here, and that the counters up here, they are updating. You can see how they are updating there, including this value here is changing as we change this. So this was a sketch that would help me to better conceptualize this visualization here, as it involves a lot of complexities. So I needed a simple way of conceptualizing this idea. So when I conceptualized this idea, it was only then that I started coding. So let's go now to my code. The code is contained in the source folder. So this is the source folder here. So the first thing is the organization. So these are the components that are rendered on the page. Here all the components that are rendered on the page are in the components. The context is to manage variables that are global variables that are shared between the components. The hooks was to read the data. The Redux was for state management, and let's briefly go over them. So here we have the components. The first one is area chart components, and I have drawn the two charts, that is the area chart and the population pyramid, using D3.js. So all these, the area chart and the population pyramid, were drawn using D3.js. That was its purpose, and I integrated it into React so that we can be able to draw some nice visualization. So all these visualizations are the two visualizations are rendered using D3.js. So the main component is where we are rendering the two components dynamically. You can see we are including a prop here to indicate the visualization that is selected. And if we go down here, we can see that the two visualizations are rendered dynamically. If the user selects population pyramid, we render the population pyramid, and then we use the data for the population pyramid. This is open here, indicates whether the sidebar is closed or open. Then we have the area chart component here. If the user selects area chart or does not select population pyramid, we render the area chart component. So that is what this main content is doing. It is either rendering the area chart or it's either rendering the area chart or the population pyramid. Then we have the layout component, which is basically wrapping, which is basically a wrapper of all the components that we are drawing, including the main content component. Then we have the sidebar component, where we are importing a table here. This table we are importing here is the table that is used to render the countries. The country codes or the country names, they are being rendered using this component here. This is the data table that is rendering that component, and it is included inside the sidebar. That's why we are importing the table here. And if we go down, then we will find that table somewhere here. This is why we are rendering the country codes. And then we have this table here, and then we have the two buttons that are loading the next data, load the next chunk. It is being rendered using this button, and then we have load previous button. Then we have the index. We are importing the key components here, which are to be used in the app.js, and we are importing them here so that we export all of them from this component. That is the index.js. Then we have the context. We have said that the context is used for managing the global variables, the variables that are shared across sorry, this is the context. I hadn't clicked this index.js here. So if I click, then we can see the variables that are being managed in the context.js. So this is basically the variables like Harvard IDX, Harvard country, current year, current group, that is the current chunk or the current group, set current group. All these things are managed at a global level. Then we have the hooks. Under the hooks, we have the hook for reading the data. We are using this use visualization data to load the two data sets, that is the population data and the area chart data. So we are loading them here, and we are loading them conditionally, asynchronously, based on the group number. If you are in chunk 1, group number is 1. If you are in chunk 9, the group number will be 9. So this is basically the hook for reading the data. Then we have the Redux, which is basically the state management tool. Redux is a state management tool where we are including various functionalities for starting the application. This is the initial state. Initial state here is 1950, learning is 4, speed is 100, and the increase by amount or increase amount by amount here is by default 1. So these are the functions for posting the visualization, for reversing, for resetting, for restarting. All these are included in the store, which is included in the application as a global variable. Then we have functions. These are the functions that I'm using in the application. The functions to draw the area chart, to read the time scale, to render the median base, to do all these things here. These are some of the functions that I'm using in the app. Then RxJS, I had said that this application included the use of React. React is used for reactive programming in the application, and for the UI, for the user interface. Then D3 is for rendering the charts, the visualization. Then we have the Redux for state management. We have seen that. Then we have the RxJS, which I want to show you now here. It is used for the animation, for looping through the different years. And yeah, this is where I am using the RxJS, using this interval function from RxJS, which is a better tool for reactive programming also. So this RxJS interval function is used to emit values sequentially. For example, 200 milliseconds at continuous interval, 300 milliseconds, 500 milliseconds, any interval that is specified by the user. So that's why here in the controls component is, if we specify 200, then 200 milliseconds. After every 200 milliseconds, we are rendering this graph. So this animation here is being controlled by RxJS, which is emitting a given amount of milliseconds in every fixed interval. So that is it about this code here. I have explained about the components. I have explained about the context, the hooks, Redux, and then let me explain about the app. The app is where we are combining all these functions here. We are combining the state from the Redux, the hooks, the context, the components, all of them, they are being combined here so that they can be exported as a single app, which is then displayed on the page using this index.html here. So basically that is the structure of my code, and that is it for this project. And in the next one, we will repeat this same project, but we will use different technologies. That is, we will use Angular instead of React, and instead of Redux, we will use Angular and GRX state management tools. That is the Redux for Angular. So until next time, thank you and goodbye. See you next time.